So in our last lesson, we talked about arithmetic sequences, and this one's going to be on geometric sequence. And a sequence is geometric when the ratios of consecutive terms are the same. The number r is the ratio for the sequence. So when you had arithmetic, you had a d for the common difference, and that was plus or minus to get from term to term. And for geometric, you have an r, which is a ratio, and that means you're multiplying. And you can think about it like dividing also, or you can think about it as multiplying by a fraction. So try to stay with multiplication. So I'm going to go kind of quick through these. Feel free to pause, use your calculator if you need to, and go at your own pace. It says determine if the sequence is geometric. If so, find the common ratio. It is geometric if I am multiplying by the same thing to get from term to term. So number 1 is a yes, and my common ratio is a 2. Number 2 is a yes, common ratio is a 3. Number 3 is a yes. Bottom numbers are being multiplied by 3, and my signs are alternating. So I'm multiplying by negative 1/3. Number 4, these are all squares, but I'm not multiplying to get from term to term. So no, this is not a geometric sequence. Number 5, multiplying by 2, and the signs are changing. And number 6, I know that's multiplying by 4, and that I can check my calculator to make sure that's multiplied by 4, and it is, and that also. And my signs are changing. So negative 1/4. And again, you can see that those numbers are getting smaller, but I still think about it as multiplication. It just happens to be a fraction. Okay, then you've got, just like for arithmetic, your a sub n equals dn plus c. D is your common difference, n is the number of term you're on, and c is the term before the first term. So for geometric, this is your formula. It is exponential because when you multiply to go from term to term, you're going to have exponential growth or decay. So that's how you can tell. If I give you a rule and it looks linear, odds are it's arithmetic. If I give you a rule and it looks exponential, now remember, exponential does not just mean it has a power, it means it has a variable in the power. Then odds are it's going to be geometric. So write the first 5 terms of the geometric sequence whose first term, a sub 1, is 3, and whose common ratio, r, is 2. So if I were to set up my formula, my first term is a 3. My r is a 2, and then it's to the n minus 1. Okay, so if I'm going to find a sub 1, plug a 1 in for your n, and 1 minus 1 would be 0. 2 to the 0 would be 1, and 1 times 3 is 3. Okay, now if I let my n be 2, 2 minus 1 would be 1. 2 to the 1 is 2, and 2 times 3 would be 6. Third term, 3 minus 1 is 2, 2 squared is 4, 4 times 3 is 12. Okay, and then for a 4, 4 minus 1 is 3, 2 cubed is 8, and 8 times 3 is 24. And for the 5th term, 5 minus 1 is 4, 2 to the 4th is 32. Nope. 2 to the 4th is 16, sorry, 16. 16 times 3 is 48. Okay, now, let's notice something. I told you that your r was 2, and I told you what your first term was. If you know this is geometric, you can just plop down your first term and multiply by 2. But you need to know how these rules work for like 2 minutes from now. But for this, for double checking it, that's totally fine. You get your first number, and then you know your R is 2, so just multiply by 2 each time. Totally fine. So number 8, we'll show both ways. I know I'm geometric. So A sub n equals first term times my R to the n minus 1. Okay, so my first term, if I plug in a 1, that would make it to the 0 power, which would wipe this guy out to a 1 and leave me with a 2. My second term, 2 minus 1 is a 1, which will give this to make this a negative 4, times 2 would be a negative 8. 3 minus 1 is 2. Negative 4 squared is 16. 16 times 2 is 32. And again, I can see multiplying by negative 4, multiplying by negative 4. Plug a 4 in there. 4 minus 1 is 3. Negative 4 cubed is a negative 64. Times 2 is a negative 128. And then for 5, 5 minus 1 would be 4. 4 to the 4th is 256 times 2, 512. And it would be positive because that would have been an even power. And again, multiply by negative 4, multiply by negative 4. Okay. This very specifically wants the 15th term, not the first 15 terms, just the 15th term. Now, I know I'm geometric, okay, so I already know this formula. First term is 20, that goes there. R is 1.05, so it's growing, but really slightly. And then to the n minus 1. So this is my A sub n formula for this geometric sequence. And then it asked me to find A sub 15. So 20 times 1.05 to the 14. And I just do this in one swoop. $39.6. It makes sense it's a decimal because I'm growing by a decimal. Okay, I want the 12th term, geometric. First term is 14. Common ratio is 1.2, growing a little bit faster this time. N minus 1, I want the 12th term. Again, I'm going to go kind of fast, but feel free to pause it, stop it, rewind it. Type that in. I got 104.02. Okay, find the 9th term. So I want A sub 9. My first term is a 4. My common ratio is a negative 1/2, so getting smaller and going to alternate signs. To the n minus 1, so this would be 8. Okay, so then you're going to very carefully type this into your calculator. And because it's fractiony, I'm going to stay fractiony. So 1 over 64. Find the 9th term. Let's see, my first term's a 5. It's definitely geometric because I can see it's multiplying by 3 each time. 9 minus 1 will be 8. $32805. Find the 12th term. First term's a 4, and looks like we're multiplying by 5. 12th term, so that would be to the 11th. Type that in. 195,312,500. Okay, so far so good. Find the 14th term of a geometric sequence if the 4th term is 125 and the 10th term is 125 over 64. Now we did this with arithmetic sequences, and we would subtract and then divide by however many spots it covered. But with this, I want you to kind of set this up like this. Think about this guy. Yeah, well, yeah, we'll go ahead and put that. Okay, so now what's the biggest term you know? You know the 10th term. So I know a sub 10. I don't know a sub 1, but I do know a sub 4. Now, think about this. How many r's would you multiply by to get from 4 to 10? And that's 6. So it's going to be to the 6th power. So don't think about this n minus 1 so much. Just think about how many times would you multiply by r to get from the 4th term to the 10th term. Now, plug in what you know, and you can solve for r. So I know a sub 10, and you got to be really careful with your algebra. And I know a sub 4. Okay, I'm not going decimals. I'm going to divide by 125. Okay, put this over 1. If I bojangles, my 125s are going to cancel. It does not leave me with a 64. It leaves me with a 1 over 64. Then to solve for r, I need to take the 6th root. So I'm going to make sure you know how to do that on your calculator. If you go to math and look at number 5, like number 4 is the cube root, number 5 is any root. So I think on mine, I hit 5 and it lets me plug it in. If you have the old calculators, you have to type in your 6 first and then hit that button under math and then type in your 1 over 64. So I want to do the 6th root of 1 over 64, and it's going to be a half. And again, stay fractions. Okay, so now I know r. Okay, it says the goal was to find the 14th term. Okay, well, I don't know the first term, so again, I'm going to modify this. The biggest term I know is the 10th term. So what I'm going to do is I'm going to use the 10th term to help get me to the 14th term. And I know I don't want you to sit here and multiply by 1/2 4 more times. I want you to set it up like this. A sub 14, the one that's farther down the line, equals a sub 10, and I could have used a sub 4 if I wanted to, but I'm going to use the biggest one I know, times r to the what? Okay, well, how many r's would it take you to get from 10 to 14? And that's 4. Now fill in what you know. I don't know him. I do know the 10th term. And now I know my r. And so you're going to very carefully type this into your calculator. And I do not want a decimal because everything in here is fractions. So I want you to pause this, type that into your calculator, and make sure you're good. If you don't, if the first time you type this in is on your homework quiz, you have no idea if you know what you're doing or not. So pause the video, go plug it in, make sure you're good. Okay, let's do that again. So here we go. Find the 8th term of a geometric sequence if the 2nd term is 6 and the 5th term is 81 over 4. Okay, so I'm using this guy. This is always going to be the one farther down the line. So the biggest one I have is the 5th term. So a sub 5 equals a sub 2 r to the what? How many r's do I need to get from the 2nd term to the 5th term? And that's 3. Now plug in what you know. I know the 5th term is 81 over 4. The 2nd term is a 6. So now I'm going to divide by 6. which is 6 over 1. I'm going to Bojangles. And I'm going to get r cubed equals, I can do some reducing with my 6 and my 81, and I get 27 over 8. Now, before you just blindly grab your calculator, guys, 27 and 8 are both perfect cubes. So when I cube root both sides, I should know that this is a 3 over 2. I should not need my calculator for that. Okay, I want the 8th term. I'm going to base it off of the 5th term. So the 8th term, the one farther down the road, equals the 5th term times r to the, all right, how many r's do you need to get from 5 to 8? I need 3 of them. So the guy I don't know, 81 over 4 is my 5th term. I now know that my r is 3 over 2. Yeah. I want you to pause this and very carefully type it in and make sure you get 2187 over 32. Okay, so we should now be getting the hang of this. I want the 7th term. I'm geometric. I gave you number 2 and number 5. So the 5th term is the 2nd term with 3 r's. The 5th term is 1/8. The 2nd term is negative 64. Divide by negative 64. That's over 1. And then our Bojangles. 64 times 8 is 512. 512 is a perfect cube. When you cube root this, you're going to get a negative 1/8. Don't lose your negative. And again, no decimals. I want the 7th term. So a sub 7 equals, now I could use the 2nd term or the 5th term, but I'm always going to use the one farther down the road. A sub 5, r to the, that'd be the 2nd. I don't know him. I know him. I now know him. Type this in and get 1 over 512. And again, pause, rewind, go back, take your time. Okay, so now we're going to find the sum of a finite geometric sequence, and then we're going to find the sum of infinite geometric sequences. Okay, so finite geometric sequence, I will always give you this formula. This is telling you that I want you to find the sum. Looking at this, I want you to be able to tell that it's geometric because it has a variable in its power. That's what's changing. This is your formula. So let's talk about what you need. I need the first term. I need to know what r is, and I need to know how many spots we're going. Okay, so this says find the sum of the terms from 1 to 12, and this is definitely a geometric sequence because it has an n in its power. So I need to figure out what my first term is, a sub 1. So I'm finding the sum of the first 12 terms. So S for sum. A sub 1, if I plug a 1 into my n, 0.3 to the 1 is going to be 0.3, and 4 times 0.3 is 1.2. Then 1 minus my r, which is this guy, 0.3, to the n, I'm going 12 terms, over 1 minus 0.3. The answer is 1.71. You need to stop this video and you need to go to your calculator and you need to type this in because so many people lose it when they type this thing in. I recommend doing it in one swoop, but I am going to caution you, when you have multiple terms on top of a fraction, you have to put in parentheses and then divide by, and you have to put that in parentheses. So just be careful. Okay, number 18, I'm finding the sum of the first 10 terms. To find my first term, I'm going to plug in a 1, because that's where I'm starting. Plug in a 1. 1 minus 1 is 0. So 0.25 to the 0 is going to be a 1, and 1 times 2 is 2. And then 1 minus, there's my r. 0.25 to the n, I'm going 10 terms. you're going to pause it and plug all that in, and when you're done, you should have a 2.67. Okay, number 19, I'm finding the sum of the first 7 terms. No, I'm not. I'm not finding the sum of the first 7 terms. I am only finding 3, 4, 5, 6, 7. How many terms is that? Because it's not 4. Don't do 7 minus 3. Or if you do 7 minus 3, remember what you have to do. You have to add 1. This is 5 terms. Now, when it asks for a sub 1, it's really, in this problem, asking me for a sub 3 because I'm starting with my 3rd term. So plug in a 3 in here. 3 minus 1 is 2. 4 squared is 16. 4 to the 5th. Plug that in. There's your answer. Be careful on that one. All right, now look at number 20. I do not have 12 terms. I have 13 terms because look at the bottom. I am starting at 0. So I have 13 terms. 12 minus 0 is 12, but then I got to add 1 back in. This has 13 terms. So the sum of the first 13 terms. Okay, plug in a 0. That's going to make this a 1. So my first terms are 4 to the 13th. Again, you're going to pause this and type it in and make sure you're getting that. Okay, the sum of an infinite geometric sequence. Okay, I know this is infinite because I have an infinity symbol up there. I know this is geometric because I see my I in my power. This formula, again, I will always give you this formula. It's super easy. I just need the first term and I need to know my R. I can't know the last term because he doesn't exist because it goes on forever. So let's see, the sum to infinity. Let's see, first term, plug a 0 because that's where I'm starting. Plug a 0 in there. That's going to wipe this out, make it a 1. So that would be a 4 over 1 minus 0.6, which is a 10. Because it would be 4 over 0.4. Make sure you're good with all the typing in. This, I'm finding an infinite sum. Plug a 0 in there. That's going to make this a 1. So my first term's a 5. My R is a 0.5. So this is 5 over 0.5. So again, the sum's a 10. It's not always a 10. This one, I'm finding the sum of the infinite geometric series. I need my first term, plug a 0 in there. That's going to wipe that out and leave me with a 7. All right, now look, do this without a calculator. 3/3 minus 1/3 is 2/3. Then Bojangles. 21 over 2. Don't give me decimals on that. Decimals tell me you're plugging it into your calculator and you're not thinking. Okay. This one, I know I'm geometric because I'm not adding. I know I'm multiplying by a 10th. So this is going to be the sum from n equals 0 to infinity. 3 is my first term. I'm multiplying each one by a 10th because the decimal's just scooting. And this would be n minus 1. You could also set it up and say n equals 1 to infinity. And just go to the n. Either way, you're going to get the same answer. So let's see. The sum, first term's going to be a 3. That's a 10th. So that's 3 over 9/10. Bojangles, that's 30 over 9, which is 10 over 3, which is 3.3 repeating, which I think is one of the ones we did from the other day. Number 25, and if I'm going too fast, it's only because I know you can pause this. Let's see, I'm going to go n equals 1 to infinity. I'm starting with a 5. and then I go to 1, and then I go to 0.2, and then I go to 0.04. If you're not sure what your R is, all you have to do is take this guy and divide it by this guy. Or take this guy and divide it by that guy. Or take this guy and divide it by that guy to figure out what you're multiplying by. So it's a 1/5 to the n. Let's see, plug in a 1. Yeah, plug in a n minus 1. Plug in a 1. I'm going to get a 5. My R is a 1/5. Bojangles. 25 over 4, which is 6.25 even. And then for this one, if I just go ahead and find the sum, first term's a 5. Let's see. Looks like it's a 1/10. So 5 over 9/10. So 50 over 9. Is that right? Yeah. Which I don't think reduces. It's 5.5 repeating as a decimal. Okay, again, I know I went kind of fast, but it's only because I know you can pause it and go back over it and make sure you're good with your calculator.